Okay. So we have to complete, go through some Kubernetes resources. Okay. Rest of some topics are related to access control. RBAC, roles, secrets. This one is config map. Okay. So these are some deep level topics related to Kubernetes. Okay. So any idea what is access control or what is RBAC, role, secrets, or config map? Any idea?
RBAC rollback access control, like we are
Sorry?
giving, coming to RBAC, it's rollback access control. We are giving certain users certain roles so that they can access only certain services rather than
Right.
accessing everyone.
Right. Yeah. Say role-based access control. What about secrets, config map?
Secrets is something like when coming to anything like AWS, Azure, or something like that, like cloud-based services, whenever we are defining uh, like uh, what we call um, creating a role wherein the role will have a secret and value. For that, we need to, whenever we are accessing those role, we have to provide those secrets so that the role can access the particular service using the secret.
Right, right, right. Hmm. What about config map? Any idea?
Not sure about config map.
Okay. Coming to access control, okay, this is actually we can call it as what happened under the access control: authentication and authorization. Authentication and authorization. So, for example, coming to EKs, okay, we can say some native access control tool is IAM, AWS IAM Authenticator. Okay. So where actually we define the, who can access a certain resources. Okay. For example, coming to Kubernetes, so we need to define who can access. Okay. For example, consider like that there is a two teams are there. Okay. One is developers, dev team there, DevOps teams also there. So DevOps teams who manage our entire Kubernetes cluster, right? I mean, they will create a node, pod, namespace. Then they are actually the administrator, right? Coming to the Kubernetes cluster. But coming to developers, okay, sometimes we define some roles and permission to the developers. So the developers can deploy application to the specific namespace, or they can read the pod, they can view the container, similar permission that we define to the developers team as well. But they can't delete any pod or delete any container or deployment on Kubernetes cluster. So similar way, we need to define corresponding team members who can access our cluster using their respective permissions. Okay. I mean, coming to the roles that we define for the specific users. So coming to secret, okay, it's a symbol like for example, we are running a database server, the database pod, okay. This is our database pod. So inside, this is a DB container. Okay. And consider, okay, give me a second. Okay. So consider we have a another pod here on the same Kubernetes cluster. So this is considered a two-tier application, okay. So this is a front-end application. And this front-end is connected with the database as well, okay. So how that front-end application access database? Coming to database have a username and password, right? Username and password there. So whenever we creating database, we need to define these all things, okay? Username. So the corresponding users can access database using provide the username and password. So coming to the front-end application, we already defined the use, how to connect that front-end application to the backend, DB using username and password. So we can define the username and password two way. One is we can define or we can provide it on the YAML manifest. YAML of the front end, okay. Coming to the YAML front end deployment, YAML manifest, we can define. Coming to the port communication, okay. We can define username and password. Username and password. But this is not best practice, right? Hard coding that credentials on a YAML manifest. Not best practice. Because credentials we didn't hard code on any of the code, okay. So in this case, what we need to do, Kubernetes offer resource secrets. So we can use the secret or we can use a resource Kubernetes on kind or resource to keep passwords or API, then some credentials, tokens, all things we can keep on the secrets. So what we need to do, we will create a separate YAML manifest. This is another YAML, okay. So in that YAML, the kind is secret. Kind secret. And here we need to define the username and password. If we define username and password here, it's by default, this is secret, right? So by default, the username and password will encrypted. It's using, I think, base 65 or 60. Some encryption is using here, okay. So for example, if anyone open the YAML file, they can't see that username and password because here we can see all the data will be encrypted. So don't worry about that. And we need to define, okay, how this port will, how this YAML or how this port will taking this secrets, we need to define where on the YAML manifest of the front-end application. So coming to the front application, we can define the username and password, okay? And here we need to define the file name only. The file name is secret file name we need to define on the YAML. So whenever the port running and whenever it will needs to take that password and username and password, it will hold to the secret file and taking that username and password, then the pod will use that and authenticate with the database. This is for not for the database only. Okay. For example, we can keep some tokens here, API, a lot of stuff we can use using secrets. Main thing is, one is it will encrypt it by default, and we don't hard code on any any other YAML manifest. We will create secrets separately in a separate YAML file, and we apply that one. Then we mapping that file, or we need to define the file name on the YAML manifest of application. Got it? Any doubt? Okay. Then coming to config map. So what is config map? Simply, we can say it's a configuration mapping. Got it. So when we learn Docker, okay, Docker bind mount. You remember that class, bind mount, all of you. Forget this one, bind mount.
Yeah, volume
I think yeah, Docker volumes. Under Docker, two types of Docker volumes are there. Two types Docker volume. One is bind bound. Second one is named volume, right? Named bound or named volume. So coming to bind bound, what we will do like we have a host machine, right? A host machine here, like a EC2 machine, okay? EC2. And we have in a we are in a directory like home Ubuntu. So this is a directory where we working. I mean, running the Docker command and everything. So this is our container. Consider like that. We have a container as well. A container, C1. And for example, if you're running Nginx application, okay, Nginx web server to deploy some application. So we can directly using Docker commands, right? Docker -d. Then we need to find the Nginx name. So Docker will installing the Nginx web server on a container. And we need to define the application index.html file as well, right? So Nginx root directory, similar like Apache bar www.html. So coming to Nginx, we can see there's a root directory, user, share, Nginx, HTML. So this is the root directory where we keeping the application code to access the Nginx service, okay? So inside the HTML directory, we need to keep the index.html file, index.html. So in this case, okay, for example, we are going to developing a, so I will explain one scenario, okay? We are going to developing a web application. developing a web application. So initial stage, we write some application code, but gradually we need to add more and more more and more lines of code on the same file, console like that. So what we need to do, we will use any of the volume. So in this case, bind bound is best for that case. Okay, bind bound. Bind bound means we're running the application, right? The Nginx is running, but there's no code we define on that specific path. So how we will specify using bind bound, we will create the index.html file on the host machine, index.html. Okay, so the index.html file we can see on the host machine. And we will bind this path with the container path. So how we will define? Whenever we run in the Docker command, we need to add that we flag, then define the path home Ubuntu. This is binding Ubuntu. This way we need to bind. Okay, double. Then we need to define the this is a source and target. Source target. No need this one. Yeah, source and target. Source is our EC2 mission source path. The target path is container root directory. Coming to the Nginx case, okay. So we need to define the user share this directory. We need to define here, ending with HTML. So what will happen? The host machine directory, this directory mapped with the container directory. So that this container can access host machine directory and file as well, because we create the index.html file here, right? So the Nginx service the container Nginx service is looking for the index.html directory to getting the index.html file, right? So in this case, the index.html file belongs to the host machine, right? But container can access the index.html file and they can expose the application as well. This is a real-time syncing, actually. Real-time syncing. Syncing means from the host machine to the container machine or container path, okay? All the files. For example, if we create another file, so the container can access that file as well. Then this is a developing case, right? So now you can see the application we deploy the application. Okay, Nginx is exposing the application as well. So if you need to add more code on the same file, just log into the host machine directory and open the index.html file and add the file just to save and exit. So this will real time syncing, right? So the Nginx can also update the latest content on the website. Got it. The bind bound is good, right? So named bound is I think bind bound I think we covered, right? But named one I remember that, like we created Docker volume, create volume name. Then we need to bind similar like this. We create a volume and we define the volume whenever we need. So coming to config map, okay. Similar thing. Similar means the bind bound. So what we need to do, for example, this is Kubernetes resource, okay. Config map is Kubernetes one of the resource. So whenever we're running a pod, okay, similar, for example, we're running a Kubernetes Nginx pod, console like that. Nginx pod. So that Nginx, this is Nginx, directly we run the Nginx pod, okay. We can define the image from, officially we can define Nginx. So it will download the official Nginx image and Nginx application from Docker Hub. So we have some requirement coming to the Nginx. Nginx, sometimes we need to configure Nginx, right? For example, leave the Kubernetes case, okay? Directly, if we install Nginx on a server, easy to machine. So coming to easy to mission, we need to deploy some application. So if we use Nginx, we directly install Nginx, right? apt install Nginx. So Nginx web server will be running on the EC2 machine. And we need to configure that Nginx application. So what we need to do, we will go to the corresponding directory. Okay, so whenever we install Nginx, the Nginx configuration directory also created. Okay, so we need to go to the etc nginx and go to the nginx configuration file, and then we need to edit that file as per our requirement. So that's the way we define, work with the EC2 machine, okay, when coming to Nginx configuration. So if we have any configuration, we need to add that configuration as well. Configuration means, for example, if we need to define the application name, uh, in this case, okay, we have Nginx, but we need to deploy two applications. So everything we need to define on that configuration file, or else we need to define reverse proxy, reverse proxy of application. Then we need to change the port number of the Nginx. These all are some stuff of, configuration. Okay, coming to the specific service. So coming to Kubernetes port, if we need to do similar configuration, what we need to do, we don't log into the pod and do on that pod container level. Okay, in that case, we can use configuration mapping. So coming to configuration mapping, what we need to do, we will create a separate YAML manifest for the configuration, and on the YAML file, we will define the configuration. In previous case, we log into the, we go to the corresponding configuration file and edit there, right? So in this case, we will define the same configuration here. And what we need to do, we will map with that Nginx port manifest. So here we have a YAML manifest for the specific Nginx port, right? So in this YAML manifest, there is a path. Below we need to define the configuration mapping if we have any configuration map. So this is our configuration map. So whenever the port will running, it will take that configuration from our machine to the container path, or we need to define as per the requirement. Got it. So whenever we go to the lab, you will get more idea, okay, out of you. Now I hope it's clear, right? Anyone have any doubt?
Maybe while doing the lab, yeah, more idea.
Okay. So config maps, secrets there. RABC. RBAC. Coming to RBAC. RBAC. RBAC is actually a role-based access control system, okay? Role-based access control. So, for example, coming to our different cluster, we have multiple users, okay? So we need to define the roles for each one so they can work with their own privilege. So, for example, multiple team members are there. So someone need a admin power to our cluster. Someone needs just some L1 keys are there. Okay, they just log into the cluster and checking all the pod is running. So they will only monitoring our cluster. So we need to define only the specific role for the user. For that case, what we need to do, we need to create a user on a Kubernetes. Then we need to define the role for the specific user and apply everything. Okay, so these all things we create a separate YAML manifest, or yeah, most of case we using, creating roles using YAML manifest, and inside the YAML manifest, we need to define. For example, if we're going to we create a user, okay, then we need to define a role for the user. So we create a YAML manifest, and we need to define this is a role, and this is for the user. Then define the permission like read, write, delete. So these are the permission we'll get for the specific user. Similar way, we need to define, I mean, that permission and policies for the users. Got it. Role is a kind actually, okay? Coming to role is a kind. I mean, Kubernetes resources. So coming to role, this role, it's a kind. So after creating role, we need to bind the role, okay? Binding role, there's a method there, binding the role. Binding role means bind the role to specific user or group. So we need to define that as well. Binding role also a kind, I mean a resources or resource within Kubernetes. Any doubt, anyone? All are following me, right?
Kind means like kind in the sense replica set is a kind. Also, load balancer is kind. In the similar fashion, role is also kind.
Right. Load balancer is not kind actually. Kind means what is kind actually? Kubernetes.
Service, right?
Uh, Not
Maybe.
service. For example, whenever we creating a application YAML manifest, so we need to define the API, right? API version.
Yeah, kind. Replica set is
API.
kind in the similar fashion. Role is okay.
Uh, Kubernetes resources, all the resources we can define as kind in manifest. For example, deployment,
Yeah, deployment.
then horizontal pod autoscaler, service.
Service, yeah.
So inside the service, we define the service type as load balancer, okay?
Yeah, got it.
Or cluster IP or not port like that. Then pod, then coming to RBC, the roles, binding. So a lot of stuffs are there coming to kinds, Kubernetes kinds. So these are the resources, Kubernetes native resources and Kubernetes node. Actually, coming to the YAML manifest, this is the main part. So Kubernetes node, this is for a deployment, and this
Yeah,
is for also the order scaling, and this is for service.
service.
So
Yeah.
that's where the Kubernetes act on corresponding kind of resource. In previous class, we go through the taint and toleration. Okay, I think you are not joined, right? Taint and toleration.
Taint and tolerations I joined, but
Not affinity, sorry.
Node affinity, anti-node.
No, affinity and not affinity. And we completed a lab as well, I think.
Okay.
Node affinity is, yeah, node affinity. So coming to taint and toleration, okay, taint and toleration. So we define the taint. I mean, we have a two pod here, okay, two node 1 and node 2. So we tainted one of them. This node we tainted, and we are going to deploy application on the tainted node. So we write the YAML manifest and define the toleration defined, and the replica is 5 console like that. So in this case, whenever we are applying the file to Kubernetes, what will happen? Some pod is on the tainted one, okay? So 2 pod running on the tainted, and 3 or 2 are running on the untainted node as well, untainted. So that's the problem when coming to the taint and toleration. So we need to forcefully deploy all application replica to the tainted one. So we need to use node affinity. So coming to node affinity, what we need to do, we label that node, okay? After the tainted one, we need to label using kubectl label, then the label, node name. So the specific board will labeled, okay? So then we need to define on the same YAML manifest, we need to define the node affinity commands we need to define here, okay? Node affinity. Then we can deploy. So we can see all the applications, the 5 replicas running on the tainted node only. So what is untainted node? Sorry, anti-node affinity. Just reverse. We have a node, so exclude the node. So we label, and if we define the anti-node affinity, that application not going to the specific node. So some cases we need to exclude application as well. Don't use that specific node.
If we taint that one, it won't get, that application won't get deployed to that node, right? Why do we need
Yes.
to declare anti-node affinity for that one?
Anti-node means it's forcefully stopping all the application deployment to the anti-node pieces. For example, if we define anti-node affinity on the specific pod, okay, pod YAML manifest. So application not deploying to any of that, tainted cases or labeled node. So it will go to the untainted or available node only.
As per the before class, you said like tainted means we are tainting it so that whenever we define tolerance,
Yes.
then only those like particular application will be deployed to that node. If there is replicas, there might be a chance of like those replicas will be deployed to other untainted nodes. But if it is tainted, and if you are not defining the tolerance, then none of the application will be deployed to the tainted node, right? Then why do we need to go with anti-node affinity? Since node affinity is something which will stop like the deployment of mm, like a tainted node, we have to forcefully like deploy that nodes, all the application only to the particular node. So what is the use of anti-node affinity then?
Okay, I will explain. This is the taint and affinity. Then anti-node affinity. So coming to taint, what is the, concept or meaning? It will make sure, right? Make sure or makes don't come here unless we define the toleration.
Don't.
So no pod will be deployed here, right? If we did not define the toleration. For example, some use case, okay, some GPU node tainted. So we have a GPU node, graphical processor unit. So only some application need the GPU power will be deployed here. So whenever we are writing the YAML manifest, we need to define that toleration. So that application goes to tainted node. So that's one of the use case. Then coming to this is node level, okay. Taint is on node on node. Then coming to affinity. So affinity, what it means, the pod prefer, okay, or it's require certain nodes. So we need to use label pod prefer or require certain node. How the pod require, prefer. We define that node affinity on the pod YAML. So the pod will asking for the request to the part of, inside, the deployment running on the specific node using affinity. For example, some pods wants run on a node labeled, okay, region US east one, or else some environment. We define the, whenever we using the node affinity, we label the node, right? First, we need to label the node. So what label actually we define here, okay? So in this case, the label is US East 1 or GPU we can label or development case. For example, environment we define its production. The similar way we can define the label. So in that case, the application pod, the pod wants to run on the node based on the label. So in this case, what will happen? That forcefully all the replicas of the application goes to the corresponding node. So coming to tainted toleration, there is a issues that is, the scheduler will schedule application if the application have the toleration, but it will looking for the untainted, the scheduler looking for the tainted one and available node as well. So all that node, it will deploy the replicas. Then the last one, anti-node. So what is anti-node means? In this case, pod avoids certain node or separates from other pod as well. Avoiding, avoids certain node or separate from other pod. So how this happen? Because we define the anti-node affinity on the YAML manifest. YAML of the application, and we define the anti-node affinity. In this case, the pod avoid certain node. We define that, for example, coming to real case, okay, some application node, no, I'm sorry, some nodes are there. So we define don't schedule, okay, don't schedule two replicas of the same application on the same node. That's one of the case. Don't schedule two replicas of the same application on same node. So in that case, what will happen? That will skip the pod deployment to the certain node using anti-affinity anti-node affinity parameter on the YAML manifest. Got it.
We do the lab on both the affinity and antinode, both of them on Friday.
Right.
Can I have the video for that one, please?
Yep, I will upload. I have to upload some videos. Today, I will do that. Okay. No, I mean, anti-node affinity and node affinity, simple term, we can say it's mm, that pod, okay? That pod will, or the pod decide which node it likes or dislike. Got it. Coming to affinity, that that pod will likes, and no, anti-node affinity is dislike. So it won't deploy on the specific node, the labeled one.
Okay.
One is not preference, okay? Anti-node is not preference, and the next, sorry, affinity is the pod reference, and pod anti-affinity is pod separation. I will share the video, okay? So just to go through the video and you will get more idea.
Okay.
Or else, whenever we go through the lab, I will include that part as well. Like, if we have the YAML manifest, I will show you how, I mean, how this works together.
Okay.
Then we have some couple of labs, right? Like config maps, secrets, so that we can cover tomorrow, okay? I mean, yep, on that lab, I will include, okay? I will try to include the affinity as well.
Okay.
Then we can wind up, right? Today's section.
Sure, I'm good.
Yep. Then see you tomorrow. Bye. Bye all. Good night.